Hello and welcome to another episode of the FDM-printed SLA-Printer. This time we solder the nanoDLP-Shield. So let's just have a look on the components that we need. We need an MP158 4 voltage regulator, an A4988 stepper driver, two 20-pin female pinhead connectors, four 2-pin female pinhead connectors, two 8-pin female pinhead connectors, three 4-pin male pinhead connectors, two 3-pin male pinhead connectors, four 2-pin male pinhead connectors, a dip switch with 3 switches, two 2-pin screw terminals, one 100 ohm resistor, four 10K resistors, one 100K resistor, one 100 farad capacitor, an IRZF44N Mosfet, and finally the PCB, where you can find the Gerber files on the Thingiverse page, where the link is down below in the comments of this video. Let's start with the two 20-pin female pinhead connectors that act as socket and inner connection to the GPIO port of the Raspberry Pi. Those are the only two components that need to get soldered to the downside of the PCB. Well, first we add just two solder points to each row of the female pinhead connectors to get these connectors fixed to the PCB while we add the rest of the solder points. Using a solder stand like this makes the task of soldering much easier, but it's not really necessary. Now let's complete the soldering of the GPIO connector by adding the other 36 solder points. The 100 ohm resistor is the R1, which is located right above the LED label. The 100K resistor is the R7, which is located right beneath the stepper driver. By bending the wires of the resistors, we prevent them from falling out when we turn the PCB upside down when we go to soldering. The first 10K resistor is R5, which is located right above the Set Stop Button label. The second 10K resistor is the R4, which is located right above the Set Stop Top label. The last two 10K resistors are R2 and R3, which are located right between the voltage regulator and the stepper driver. Let's just cut off the excess of the wires of those resistors that we already soldered, so we can get better access to the other resistors in the back of the PCB. Let's continue with the dip switch and let's align the switches 1, 2, 3 so that they are matched with the MS1, MS2 and MS3 of the stepper driver, just to prevent confusion when we at a later point in time will configure the microstepping. Let's install the Mosfet next. Make sure that the pins of the Mosfet are correctly aligned with the gate, drain and source labels indicated on the PCB. Now let's install the 100 microfarad capacitor right beneath the stepper driver. Watch out for the right orientation. The capacitor has an indicator for the minus pole that need to be aligned with the corresponding indicator on the PCB. Now we install 2 of the 3-pin male pinhead connectors for the Z and stop switches. I use some blue painter's tape to keep those components in place until they are soldered. It turns out that the blue painter's tape is not the perfect solution to keep the components in place. They are slipped out a little bit, and so I have to heat up the soldered joints again and push the components right in place. Next are the 2 2-pin male connectors for the LED and the stop key. Next are the two 4-pin male pinhead connector for the I2C LCD display and the next-gen display. Now we install the 4-pin male pinhead connector for the stepper motor. Now it's time to install some kind of socket to get our daughter PCBs, the stepper driver and the voltage regulator installed. We use some female pinhead connectors for that purpose. We start with two 8-pin female pinhead connectors for the stepper driver. Just a short test fit of the stepper driver, just to make sure that it fits to the socket. The socket for our voltage regulator is based upon 4 2-pin female pinhead connectors. To get them easier installed, we make use of our voltage regulator PCB. We just apply temporarily the 4 female pinhead connectors to get them easier installed. Once the 4 2-pin female pinhead connectors are soldered in place, we can remove the voltage regulator PCB for the moment. Once all the soldering is done, we will reinstall the voltage regulator and the stepper driver permanently. But in the meantime they are better removed so they cannot get damaged accidentally by overheating them. In the meantime I started already installing the last 2 2-pin male pinhead connectors for connection of the fan and the 5V output for a HDMI display. Well, we're almost finished. The last 2 components that we need to solder in place are the 2 screw terminals. The one is for the 12V input and the other one for the 12V for the UV LEDs. And finally we can install the stepper driver and the voltage regulator on their sockets. This is most important. Double check that both daughter PCBs are oriented the right way, otherwise those components can become damaged permanently. Also, the voltage regulator must be adjusted to provide exactly 5 volts. If this is not properly done, also your components can become damaged permanently. If you don't know how to adjust this voltage regulator, I have another video that explains exactly how to do this. Well, we are done. I hope you enjoyed this video, and also I hope to see you maybe next time when I come back with another video about the FDM printed SLA printer.